Hey everybody, welcome to another deep dive. We always get the most interesting questions from you guys, and this time we're going to go deep on some of the biggest mysteries the universe has to offer.
Yeah, and the stuff is like right at the edge of what we know, right? It's the stuff that keeps scientists up at night.
So we've got some seriously weird stuff to talk about, so let's jump right in. One of the things that's been really fascinating me lately is this thing called the Cooper Cliff. Have you heard about this?
Oh yeah, the Cooper Cliff, if that's a good one.
So, way out past Neptune, right? You've got the Cooper Belt, this region of like icy objects and dwarf planets.
Like the solar system's junkyard.
Right, exactly. But then at a certain point, the number of objects just like drops off a cliff. It's like hitting a wall in space.
And we don't really know why it happens. Our models predict that there should be more objects out there.
Yeah, so what are the theories? Did like a giant space vacuum cleaner come through or something?
Well, one idea is that the matter density out there is just too low to form larger objects.
Okay, so it's just kind of like a cosmic desert.
Yeah, sort of. But then there's another theory that's even more intriguing.
Okay, I'm all ears. Let's hear it.
Some scientists think that there might be a rogue planet out there, something maybe even bigger than Earth.
Whoa, hold on. You're saying there's like a hidden planet lurking in the outer solar system?
That's the idea. And that this planet basically plowed through the Kuiper Belt and swept away a bunch of objects.
Okay, now that is officially on my cosmic bucket list, to find a hidden planet. All right, well, speaking of unexpected behavior, let's talk about the flyby anomaly.
Oh yeah, this one's a real head-scratcher.
So basically, we use gravity assists, right, to speed up spacecraft, like using a planet's gravity to give them a boost.
Yeah, it's like a cosmic slingshot.
But sometimes spacecraft gain more speed than they should during these flybys.
And sometimes they don't. It's like the universe is playing dice with our spacecraft.
So unpredictable. Is there like a pattern to it?
It seems like most of the anomalies happen during non-equatorial flybys. So maybe Earth's rotation has something to do with it?
So even our own planet has some secrets up its sleeve. All right, well, we've got a potential hidden planet and a gravitational quirk that messes with spacecraft. It seems like our solar system is full of surprises. But let's go even further out beyond our little corner of the galaxy. Ever heard of an ultra-luminous pulsar?
Yes, this one is really pushing the limits of what we thought was possible.
So tell me, what makes this pulsar so special?
Well, imagine a pulsar, right? A rapidly spinning neutron star that emits beams of radiation.
Okay, got it. It's like a cosmic lighthouse.
Right. But this pulsar is way brighter than it should be, like ridiculously brighter.
What do you mean, like brighter than a supernova?
It's so bright that it breaks the Eddington limit, which is supposed to be like the maximum brightness for an object based on its mass.
So it's like a cosmic rule breaker.
Exactly. Scientists are still trying to figure out how it's possible. One idea is that the geometry of the matter falling into the pulsar is just really weird. Like it's creating an illusion of extreme brightness.
Okay, so it's like a cosmic magic trick.
Something like that. It's definitely one of the most puzzling objects we've ever discovered.
All right, so we've got a missing planet, a gravitational anomaly, a rule-breaking pulsar, and now let's talk about ultra-high energy cosmic rays. These things hit Earth with so much energy, it's like they're coming from a cosmic particle accelerator.
And here's the weird part. The heavier the particle, the less scattered it is.
What? That doesn't make any sense.
It's like the laws of physics are taking a holiday. It suggests that these cosmic rays are coming from somewhere relatively nearby, but we haven't been able to pinpoint the source.
So who are the prime suspects in this cosmic ray mystery?
Well, some astronomers think it could be neutron stars with super strong magnetic fields, or maybe supernovae, the explosive deaths of massive stars.
Okay, those are some pretty powerful candidates, but are there any other theories out there?
Oh yeah, there are some even wilder ideas floating around.
All right, hit me with the wildest one. What's the craziest idea about where these cosmic rays come from?
Some physicists think they could be remnants of dark matter annihilation, or even miniature black holes evaporating.
Mini black holes. Now that's just getting ridiculous.
I know, right? But that's what makes this stuff so exciting. We're talking about truly exotic possibilities.
Okay, so we've got a moving planet, a gravitational anomaly, a rule-breaking pulsar, and cosmic rays that shouldn't exist. It sounds like our universe is straight out of a science fiction movie.
And we've only just scratched the surface. These mysteries raise fundamental questions about our understanding of the cosmos, questions that we'll delve into even further in just a bit.
I can't wait. This is getting good.
Oh, it's going to get even weirder, trust me.
All right, folks, stay tuned for more mind-blowing mysteries of the universe. We'll be right back. Welcome back, everybody. So before the break, we were talking about some pretty wild stuff like pulsars that break the brightness rules and cosmic rays that shouldn't exist.
And we're just getting started. There's a whole universe of mysteries out there waiting to be explored.
So let's talk about matter and antimatter. Like, you know how they're supposed to annihilate each other? Poof, gone.
Yeah, it's like the ultimate cosmic showdown.
But here's the thing. Why is there so much more matter than antimatter in the universe? Shouldn't they have, like, canceled each other out at the Big Bang?
That's the big question. It's called a baryon asymmetry problem, and it's one of the biggest mysteries in cosmology.
So did antimatter just like get lost on the way to the party?
We don't know. There must be some unknown mechanism, some difference in the laws of physics that favored matter over antimatter.
So it's like the universe has a slight preference for matter?
Yeah, it's like a tiny imbalance, but it had huge consequences. It led to the universe we see today.
But imagine if antimatter had won out. Could there be like antimatter galaxies out there with antimatter stars and planets?
It's a fascinating thought. While it's highly unlikely based on what we've observed, it's not entirely impossible. There could be entire regions of the universe dominated by antimatter.
Whoa, that would be trippy, like a mirror image of our own reality. Okay, well, let's bring things back down to Earth, literally. Speaking of mind-boggling energies, have you ever thought about how hot the sun's corona is?
Ah, yes, the sun's superhot corona. It's a classic puzzle in solar physics. The corona can reach temperatures of millions of degrees, which is much hotter than the sun's surface.
Wait a minute. How can something be hotter than its source? Isn't that like breaking the laws of thermodynamics?
It is. Heat shouldn't flow from a cooler to a hotter region, but the sun's corona does it anyway.
So what's the explanation? Does the corona have like a secret stash of cosmic lighters or something?
Well, scientists believe it has to do with the sun's magnetic fields. These fields can get all twisted and tangled, and they release energy in a process called magnetic reconnection.
So it's like a cosmic game of Twister where the sun's magnetic field lines get all knotted up and release a burst of heat.
That's a good analogy, and the Parker Solar Probe, which is currently studying the sun, is gathering data that will hopefully help us solve this mystery.
Wow, it's amazing that we can send a probe so close to the sun. It's like sticking your hand in a campfire to see how it works.
It's a testament to human ingenuity and our desire to understand the universe. But, speaking of unsolved mysteries, let's shift gears to something a little different, lithium.
Lithium? Like the stuff in batteries. What's so mysterious about that?
Well, it seems that stars with planets have less lithium than those without.
Really? What happened to it? Did those planets steal it for their batteries?
Haha, well, that's one theory. But the more likely explanation is that the gravitational pull of planets causes lithium to sink into a star's core where it gets destroyed.
So it's like planets are slowly draining their stars of lithium over billions of years.
Exactly. And this observation has an interesting implication. Studying lithium levels in stars could be a new way to find planets.
Whoa, that's like cosmic detective work. But speaking of unexpected connections, did you hear about that Roman shipwreck that might hold the key to understanding why the universe exists?
Ah, yes, the ancient Roman shipwreck off the coast of Sardinia. It's a fascinating story that highlights the interconnectedness of science history and a bit of bad luck for those ancient mariners.
Wait a minute, a shipwreck? What does ancient Rome have to do with the universe?
Well, the shipwreck was carrying over 1,000 lead ingots.
Lead ingots, like the stuff they used to make pipes.
Yeah, exactly. But here's why it's important to physicists. This ancient lead has been shielded from cosmic rays by seawater for centuries, so it's incredibly pure.
And why is that important?
Because they need ultra-pure lead for experiments like CURE, the Cryogenic Underground Observatory for Rare Events.
What's so special about CURE? What are they trying to find?
They're searching for evidence of neutrinoless double beta decay, a very rare event that could tell us a lot about the nature of neutrinos.
Okay, I'm going to need a little help with this one. What are neutrinos and why are they so important?
Think of neutrinos as like ghosts of the particle world. They're tiny, almost massless, and they barely interact with matter. They pass through us all the time without us even noticing.
So they're like cosmic ninjas.
Yeah, kind of. But here's the thing. If neutrinos are their own antiparticles, it could explain why there's more matter than antimatter in the universe. That pesky baryon asymmetry problem we talked about earlier.
So this ancient Roman lead, which was probably used for plumbing or something back in the day, could help us solve one of the biggest mysteries in physics. That's incredible. But are they really melting down these historical artifacts for their experiment?
It's a delicate balance between preserving history and advancing science, but the potential payoff is huge. By studying this ancient lead, we might unlock secrets about the universe's earliest moments, about why we exist at all.
Okay, my mind is officially blown. We've gone from a mysterious surplus of matter to a Roman shipwreck that might hold the key to the universe. It's like everything is connected.
Absolutely. And speaking of mind-blowing ideas, have you ever wondered if we're living in a simulation?
Hold on a second. Are we going down the Matrix rabbit hole?
Maybe. But it's a question that some serious physicists and philosophers are considering. If our universe is just a highly advanced computer simulation, it might explain some of the strange things we've been talking about.
Like the hidden planet, the rule-breaking pulsar, the surplus of matter. You're saying it's all to the heart of the program?
It's a radical idea, but it's not entirely implausible. Our own technology is advancing so rapidly. Imagine what a civilization millions of years ahead of us could create. They might be able to simulate entire universes.
Okay, that's pretty freaky, but how would we ever know if we were living in a simulation? Like, short of seeing those glitches in the Matrix, are there any clues?
It's a tough question. Some have proposed that we might be able to detect subtle limitations in the laws of physics, like finding a cosmic pixel or a limit to the precision of certain constants.
So we're looking for cracks in the code.
Yeah, something like that. But for now, it remains a tantalizing possibility, a question that may forever linger in the realm of speculation.
Well, if we are in a simulation, I demand to speak to the manager. But, this makes me wonder about the nature of the real universe. Is it a boring place compared to our simulated reality? Or is it even weirder?
That's an excellent question, and it leads us perfectly to the concept of the multiverse, the idea that our universe is just one of many, perhaps an infinite number of universes.
Whoa, whoa, whoa. Are you saying there could be infinite realities out there? Each with its own laws of physics, its own history, its own everything?
Exactly. It's a concept that truly stretches the limits of our imagination. And there are different types of multiverses. For example, imagine a quilted cosmos, an infinite universe with repeating patterns where there's another you out there living a life almost identical to yours.
Okay, that's just getting creepy. What other kinds of multiverses are there?
Well, there's the inflationary multiverse where bubble universes are constantly being created, each with its own unique set of physical laws and constants. And then there's the cyclical multiverse, where universes go through cycles of expanding and contraction, Big Bang, followed by Big Crunch over and over again.
Okay, my head is spinning. So many universes, so little time. But, there are some people who say we shouldn't even be thinking about multiverses because they're impossible to prove or disprove.
True, but the point is that the possibilities are endless. And that's what makes exploring these concepts so exciting. It pushes us to think beyond the boundaries of what we know and imagine, realities that are far stranger than we can comprehend.
Okay, I need a moment to process all of this. Unseen planets, a pulsar that breaks the brightness rules, a Roman shipwreck explaining the universe, and maybe even a multiverse. This deep dive is definitely living up to its name. But now I'm curious, what happens when the universe ends? Does the simulation just shut down? Do we get a game over screen?
Ah, yes, the ultimate question, and one that has fascinated and terrified humans for millennia. Let's just say it's not going to be pretty, whether we're in a simulation or not. But don't worry, we'll explore the various theories about the universe's eventual fate, and trust me, it gets even weirder.
Okay, I'm ready. Bring on the cosmic apocalypse.
All right, then let's journey to the end of time and beyond.
Okay, so we're back. And I gotta say, thinking about multiverses and simulations is pretty wild. But now I'm kind of curious, what happens at the end of it all? What's the ultimate fate of the universe?
Yeah, that's the big question, right? The one that's haunted philosophers and scientists for centuries.
So paint me a picture. What does the end of the universe look like?
Well, imagine trillions of years in the future. The universe is expanding, cooling down, stars are starting to die out, and everything is really spread out and dark.
Okay, that sounds kind of bleak, like a cosmic ghost town.
Yeah, it's not a very cheerful picture. This era actually called the degenerate era.
Degenerate era? What's so degenerate about it?
Well, it's the era of stellar remnants, like white dwarfs and neutron stars, the leftovers from dead stars.
So no more shining stars, no more new planets forming, just a bunch of burnt-out sinners.
Pretty much, it's a much colder, darker universe than the one we know today.
Okay, I was hoping for something a little more exciting, like a big crunch or something. But wait, you mentioned black holes earlier. What happens to them?
Ah, yes, the black holes. In the black hole era, they become the dominant force in the universe.
So they just go around swallowing up everything that's left?
Yep, pretty much. They grow larger and larger until eventually even they start to evaporate.
Hold on, black holes can evaporate. I thought they were like inescapable cosmic vacuum cleaners.
They are incredibly powerful. But even black holes eventually lose energy through a process called Hawking radiation.
So even the mightiest black holes eventually fade away. So what's left at the end? It's a big empty void.
Well, not quite. Remember those quantum fluctuations we talked about, those tiny ripples in the fabric of reality?
Yeah.
Those would still be happening, even in a universe that's reached maximum entropy.
Entropy, that's like a measure of disorder, right?
Exactly. So in this state of maximum entropy, things are as spread out and random as they can possibly be. But even then, there's still a chance for something to happen.
Okay, you're starting to lose me. What could possibly happen in a universe that's completely run down?
Well, there's this mind-boggling idea called Boltzmann brains.
Boltzmann brains. Now that sounds like something out of a sci-fi movie.
It kind of is. The idea is that in an infinite universe with infinite time, even the most improbable events become possible. And one of those improbable events is that random quantum fluctuations could spontaneously assemble themselves into a conscious brain.
Wait, are you serious? You're saying that a brain with thoughts and memories and everything could just pop into existence out of nothing?
That's the theory. It's a pretty wild concept, but it raises some profound questions about the nature of consciousness and the universe.
Okay, I think I need to lie down after this. That's a lot to process. So are you saying that our own consciousness could just be a random blip in the vast cosmic void?
It's a possibility, and it's just one of the many mysteries that the universe holds. I think the main takeaway here is that we still have so much to learn about the cosmos, and that's what makes it so exciting.
You're right. This whole deep dive has been an incredible journey. We've covered so much ground, from hidden planets to rule-breaking pulsars to ancient Roman shipwrecks to multiverses to Boltzmann brains. It's been a wild ride.
And it's just the beginning. There's so much more out there to discover. Who knows what amazing things we'll find in the years to come.
Well, on that note, I think it's time to wrap up this deep dive. But before we go, I want to thank everyone for listening and for sending in your amazing questions. Keep exploring, keep questioning, and never lose your sense of wonder.
And remember, the universe is full of mysteries waiting to be uncovered, so keep looking up.